Gigo.
Artificial intelligence can make life more convenient. The AI Educational Blocks Kit is excellent for learning about artificial intelligence. There are two key parts to the AI Educational Blocks Kit. First is the Gigo AI Control Box, and second is the Gigo Lithium Battery Holder. The Gigo AI Control Box has a built-in 5-megapixel camera that can be rotated through 180 degrees. In addition, there is the microphone, color LCD screen, and 2 buttons. Micro SD slot, PC connection port. On the reverse side, there are 8 Gigo connector ports, an external power supply, 12 DuPont ports, and a pair of speakers. The Gigo Lithium Battery Holder is also a 5V 2A power bank. It has a USB port to power devices and a micro USB port for charging. It is important to use the 18650 lithium battery. The power switch for the holder is on the side. The built-in camera on the Gigo AI Control Box makes it easy to do image recognition training. Experience machine learning by actually performing image recognition and classification. There are many ways to transfer programs and data. You can use a micro SD card, a micro USB connector, or Wi-Fi. The set has an instruction book with 20 lessons covering beginner topics to challenger missions. Use programming skills to bring the blocks and models to life. Models can be operated by remote control or programmed. Program models can track objects, interact with the environment, classify images, recognize voices, collect data, and perform dynamic image processing. Building blocks can be used to assemble various smart home and AI devices. Each set contains 147 components and is suitable for children aged 10 and up. Experiment with a variety of programming languages. Each can be used to complete the course material and integrate with the models. There used to be an artificial intelligence bot called the AlphaGo. It was a powerful AI and won World Computing Chess Championship, shocking the world. All AI can be improved through machine learning, which simulates the learning functions of the human brain. They continue to improve based on the information they learn. AI will be very diverse in the future. Today, Peter's thoughts will introduce some basic AI concepts. Yes, you guessed it. The product we are going to introduce today is 1206 AI Educational Blocks. This set is suitable for children 10 or older. But if you're not 10 yet, don't worry. As long as you're accompanied by an adult, you can still play with the set. There's a unique component in the set, the Gigo AI Control Box. The Control Box is different from other available AI tools. The main difference is this is a true AI. What does that mean? Well, you can take pictures of objects around you and then use them to train the AI so that it can recognize new and different items. Another feature of this set is that it can be used with Web AI Blockly, which is a web page used to program it. Web AI has many functions such as variables, logic gates, math solvers, arrays, and more. There are even some advanced functions which can be imported to the Web AI Blockly interface, then sent to the control box as a program. This means we have lots of functions to explore, and there are more than 20 models we can make. So that's the box. Let's open it up and have a look inside together. These are all the 1206 components. And you can see that in addition to our usual C-series parts, there are also some parts like tires, light bulbs, body plates, and a few other bits and pieces. There are two really unique pieces with the set, which are 18650 lithium battery holder Gigo AI control box. First, the Gigo AI control box. You can see it has a camera on top here, and that can rotate 180 degrees. It has 5 million pixels. It'll need that resolution to take clear photos. It needs good quality photos to be able to identify objects accurately. There are 4 holes on this control box, and these 4 holes are for the microphone. If we need to use the speech recognition function, then the control box will need access to the microphones. Over here on the left side is the PC connection port. As long as we have a USB cable, we can connect the AI control box to a computer. Doing that, you can import programs or enable other functions on the control box. The lower slot is the microSD card slot. So this SD card slot is useful because it allows you to expand the storage of the device. When we use the speech recognition function later, we'll need that extra space to store the voice messages. So, this is the SD card slot. Now, going back to the front again. In the middle, we have our 2.3-inch LCD screen. The screen displays status updates about the AI control box, or shows camera images after they are taken. It also displays images that are being recognized by the device. Next are the L and R buttons. These 2 buttons can control some basic settings, or you can use them in case where you have to configure them in some code. Right, that's the front all finished. Now let's look at the back. There are 4 bars on the back side. These 4 bars are the speakers. Any sound made by the AI control box comes from here. You can also see that there are 8 little holes next to them. These 8 holes are the Gigo ports. The motors or force sensors are connected to these ports. In the middle are the DuPont ports. This DuPont port can be used with the 180-degree servo motor or the line tracking sensor. If you have an external sensor and want to connect it, you can use these DuPont ports. Finally, let's have a look at the hole on the button side of the device. There's also an external power input. This power input can be used to connect the Gigo lithium battery holder. This ensures there is a stable power supply for the control box. For safety, the cover of the lithium battery holder cannot be opened easily. To open it, we'll need a coin, or something similar. Here you can see, there's a coin slot. We just put the edge of the coin into the little groove. Twist clockwise and it unlocks. When you hear the click, then that means the cover can be opened. Now, if we examine the grooves here, there's a small recess. If we press on the recess area, the cover pops open easily. Then you can insert, remove, or change the lithium battery. Remember to always check the polarity of the battery when you insert a new one. Then, as you replace the cover, listen for a click. That'll make sure the coin slot has returned to its original position. Once it's locked, then the assembly is complete. Each set has a full color manual. There are detailed descriptions, real-life applications of the scientific principles, and a detailed assembly steps. As long as you follow the steps in order, assembling any of the 20 models should be easy for you. Now, let's look at a second lesson in the manual. This one is the AI sorter. Let's put it all together and run the test with the 1206 AI educational blocks. Here are the parts. First, let's assemble the model quickly. Then, I'll show you what the sensors can do. After that, we'll start programming. Okay, let's begin. Now, we finished the AI sorter. You can see it uses two lights. One is red and the other is green. There's also a 180-degree servo motor. To function correctly, this model needs our $5 and $10 cards. What we do is put this card in front of the camera, and then the camera will send commands to the servo motor. If a $5 card is detected, the AI sorter sorts to the left, so we put it on the platform. And it falls to the left side. If a $10 card is detected, the AI sorter will move it to the right. Basically, it's an automatic classification system. Next, we'll start to write the program. First, the model needs to be completed and the AI control box must be connected to a computer. Also, remember to do a firmware update. Check your Wi-Fi connection and insert a SD card. Then, we can start programming. Okay, we'll pull the slider down to find the Web AI option. Click Board. Then select the Use Wi-Fi Control Web AI to block. Here is your device ID. The device ID of this AI control box is 6DC263. Make sure that the device ID of your AI control box matches the one above. You may need to adjust it according to your AI control box. Next, click Giggle and adjust the sensors first. The two LED lights have to be turned off first. This prevents accidental activation. Now, add the block to control the LED lights. Then, add a block to control the servo motor. Copy it so you have two LED blocks. The green light on the right side connects to pin B, and status should be set to off. The red light of left side connects to the pin F, and set status to off. That way, it won't light up when the device starts up. For the servo motor, how many degrees do we want to move? Initially, the model needs to be level. So, people often think it should be set to 0 degree, but actually, if you take a look at the servo motor, you'll see a bump on the right-hand side. The angular change is calculated from the bump here. So it rotates from 0 to 180 degrees like this. You can think of this side as a pointer.
Right now, it's pointing to 90 degrees, which is perpendicular to the starting angle, and the final angle is 90 degrees. Therefore, if we want to make it level, it should be 90 degrees. So we input 90 here. After you enter and run the program, it may still be a little crooked. This occurs because there will be some calibration to do. That's okay though, we just need to make a little adjustment. For example, if it's a bit low, we just need to move it up. So we can try changing it to 100 degrees rather than 90 degrees. In this case, we don't need to make any changes. We'll keep the setting we have. Next up, we have to set the categories. This relies on the image classification function. We want it to distinguish $5 from $10. So choose image classification. Add this block. Then the first thing we have to do is select the model. You'll see that there is a 2.1 option. What does that mean? The model will use the Dropbox file labeled 2.1 for image recognition. The 2.1 file has been trained to recognize the $5 and $10 cards. So choose that one. If you don't have the option, reconnect your AI control box, then delete this block. Delete it and then try adding it again to see if you have the 2.1 option. If you still don't see it, you can manually download and install it by yourself. Next, we're going to enter our categories. This is a very important step because there are 3 situations involved in image classification. The first is no card, which we'll call empty set. So it's neither $5 or $10. It could be anything, just not the $5 or $10 card. The AI refers to it as empty set. To define a category, we enter BNULL. The name BNULL must not be changed because it is preset in the image recognition model. After entering BNULL, put a comma. The second situation is identification of $5. We call this one 5-1 to represent the $5 card. This is the second situation. Okay, put another comma in there. The third situation is identification of $10. So we call this one 10-1 to represent the $10 card. After typing it in, hit enter to complete the block. There are a few other things you'll need to pay attention to. First is the name of the categories. Because you can't create new names for the empty set, make sure it appears exactly as it is on the screen. The second is the order. Be sure to enter BNULL first, 5-1 second, and 10-1 third. This way the classification will operate correctly. Finally, remember to choose 2.1 as the model. After completing these settings, we can continue to write the program. Click Loops and add a repeat forever sync to block. Do not check sync. We want to make it repeat the identification process. Next, click Image Classification and add the Start Identification block. This will tell the AI control box to begin identification. We need to know if it recognized items correctly, so we want the result displayed on the screen. Navigate to Web AI, click LCD screen, then add the LCD display and text block. We want the screen to show what the AI detects. We don't want it to just display the names, so delete that. Let's change it to show something meaningful. Click Text. Then add a Create Text With block. Then the thing I wanted to display has 3 options, but there are only 2 grids. To fix that, Click the blue gear and pull the option in. After that, it shows 3 grids. Click the blue gear again to complete the operation. Now we have 3 grids. I'll put the following blocks in. First, from image classification, add get to identification name. Then, add the get identification confidence at the bottom. I also want a slash in the middle, so click text again. Add the empty block and enter a slash. This will separate the name from the confidence value. Right, let's check it again. After the scan, the first thing displayed is the name, with the categories above. For example, it might show BNULL 51 or 101. And after that, it tells you the confidence. The confidence would be a number in the range 0 to 1. If it shows 0.5, then that means it has a 50% likelihood that the guess is correct. If the confidence number is higher, then the accuracy of the guess is likely to be higher. Here you can change the text color. We'll keep it as it is for now. We can also set some conditions. Click Logic. Add an if to block. And 2 more. One is going to be the AND block. The other one will be equal. Now we have it set up so that if something equals something and something, we do this one step at a time. Let's keep going. First, set the model to see the $10 card. Copy the Get Identification Name block. If the image it recognizes it, then it's $10. We need to add an empty block again. Enter 101 to set a condition. Then we copy the block to set more conditions. Change this to Get Identification Confidence. We can adjust bigger or smaller here. Here we'll use bigger. How much is the confidence greater than? Click Math and add a 0 block. Let's say the value is 0.8. Seems complicated, right? Think about it like this. When the program recognizes the $10 card, the confidence value is quite high. However, it may be affected by ambient lighting or some other environmental factor. Although the confidence we enter is 0.8, you may need to adjust it according to your own situation. Next, what should it do after it detects the $10 card? The model should move the $10 card to the right. So we need to turn on the right LED light first, because we already know that the right LED light is on pin B. We can select On to turn on the LED light. The second thing we have to do is make the screen say the $10 card has been recognized. We can copy these blocks and then delete the Create Text with. Because I just want the screen to show 10-1. Great, we have a program that would turn on the light and display 10-1 when it sees a $10 card. Next, let's do the servo motor. I wanted to change the angle. I'll adjust both code blocks to pin P7 first. When we can change the angle value, we already know that 90 degrees is horizontal. So here we will make it rotate to the right. We use 90 degree as our basis and adjust it from there by about 40 to 50 degree. Let's try 50 degree here to get started. Make sure it rotates down this way. Clockwise is towards 0 degree and counterclockwise is towards 180 degree. Because it is going to rotate clockwise, we need to subtract 50 from 90. When it turns from 90 degree to 40 degree, the $10 card will be swiped off to the right. Then, we give it a buffer time of about 3 seconds. And this is what it will do when it detects the $10 card. Next, click the blue gear. Pull this else if at the bottom. You'll find that the second condition, else if, appears below. This condition is for the action that recognizes the $5 card. So, basically, the program and settings are similar to the $10 card one. Let's change it so that it turns on the left LED light and turns left. Here we can copy all 4 programs, then edit them one at a time. Right, let's start here. Change the identification name from 10-1 to 5-1. We won't adjust this confidence value. We'll adjust it after we've done some actual testing. We need to change the light to pin F and select On. Next, it should display 5-1 on the screen. So change 10-1 to 5-1. Next, adjust the servo motor angle. Before we change 90 degree to 40 degree, but here we need this one on to turn the other way counterclockwise. So we add 50 to 90, which gives us 140 degree. Remember 90 degree is the basis value for working these things out. After this, there's a wait 3 seconds instruction. Then, we tell the servo to return to the start position. So we can continue identification. So, go back to the top and copy the program again. That'll make sure that after it separates the $5 and $10 cards, it'll go back to the start position correctly. Remember, this block should not be placed inside the if block. Otherwise, only the $5 card will trigger a servo motor return to 90 degree. And $10 will not, so pull it under to $5 program. To make the platform go back to level after either situation. After that, let's copy the LED program and pull these to the bottom. Make sure the programs for both LED lights are copied and the pins are B and F. All programs are now complete. This is what the programs for the AI sorter. Let's run through the steps again. First, adjust the status of LED lights and the servo motor angle. Turn off the LED lights and keep the servo motor horizontal. Then we set some categories. Remember to choose Program 2.1. Then also remember the names and order of the categories. These must be the same. Instruct it to repeat the image recognition process. After image recognition, the model should display the image name and confidence. According to the name and confidence, make a conditional sentence. If the recognized name is 10-1 and it has enough confidence, then the platform should turn right. The LED light B on the right turns on and the screen displays the correct task. Next is the servo motor. Make it turn to the right so it's 40 degree. Wait for 3 seconds after rotation. Now, if the situation is recognize $5, the platform turns left. The LED light on the left turns on. The servo rotates to 140 degrees and waits for 3 seconds. At the end, all programs should return to the start position. Well done, that's it, we're all done. Hit the execute icon in the upper right corner, and you can transfer the program to the AI control box. After that, we'll test it and see how it works with the model. Now let's see how it goes. First, we turn on the switch for the 18650 lithium battery holder. See here, the platform has changed from inclined to horizontal. Remember, this was how we set it at the beginning. That way, there is a level platform for the cards. The first thing to do is test this $5 card. It should be sorted to the left. Let's test it. Great, the card was stored correctly, and the platform returned to horizontal. Next, let's test the $10 card. Put it on the platform. Sometimes you may need to move it slightly. Perfect! The $10 card was sorted correctly to the right.
The main page looks like this. There's a version AI platform, and if you want to start using it right away, you can log in with a Gmail account or stop and register a separate account. Then it appears on the Vision AI platform. Language settings are in the upper right hand corner. Let's change it back. This is a section for model training and image classification. While training, we can find 2 parts to do a demonstration. After you've seen these 2 parts, then I'd like you to do a short assignment. So, this demonstration will be different from the assignment, but it'll help and you can use some parts of it. Click the Add button to add models. I'm using 2 cubes of different colors. I create a category. Type red here. After creating a new category, I can upload images directly. Or a better way might be to use Web AI directly. On Web AI, it will ask you for a device ID. If you don't know the ID, you'll have to unplug the power cable and restart the control box. When it has restarted, it'll show the device ID when it turns on. This one's 60C3DE. Okay, put that here. 60C3DE. Once that's done, you get the option to rotate the camera. Either way is fine. You should probably turn it on to take better pictures. If you finish the settings, you can click the Create Category button. Then it'll send the instruction to the control box. It sends the commands out, and now we can use it to take photos. Here I can rotate the camera. The lens appears here. And this is where we train the model. The model I just trained is this one here, red. Now take photos here. Because identification requires different angles of the model. Remember that we have to take at least 20 photos of each thing. This is the number of photos you've taken so far. Press here and it will start taking pictures. Now, do the front side in the center and the little to the left. Now a bit to the right, the top, and the button. A few from upper left, some on upper right, now the lower left, and lower right. After 20 photos, they will upload automatically. Now, go back to the main screen. You can see that we have built the first model. After creating the red model, the screen will show that the upload is complete. Next, let's create another category. We have to do the same thing again. The things we want to classify are trained. Next, click Model here. To add a model, set the model name as test. After that, over here, we use select category to choose from the categories. Now, here, the order matters. Check these three. Then create a model. After creating a model, it is training. When the training is complete, let's take a look at what we've done. Remember, the category names are like this, and the sorting order matters. The sorting order affects classification. We click to download a model, and it can be recorded in the main control box. If you train something different every time, you must download the correct model to use. Here you can download the model and enter the device ID 6DC3DE. After that, click here to download the model. You'll send the commands. Then, if you look at the main control box, you'll do a quick restart. Then, download the model. When downloading, you must wait until it gets to 100%. If you have more pictures or categories, it would take longer. Once it's downloaded completely, we can enter any data we like when we write the program. Something pre-configured, so hit Open and import a preset program. Like this. This was the one we wrote before. We will send our program to the Giggl AI control box. The difficult part of this is to set the model. In the manual, there is a model that has already been trained. But we just retrain our own model. Here's thought. If we just train our own model, we now have to select a new one from the menu here. What if there is no other options? Well, you may have to check if it is trained on your machine, or if you haven't used it. You can just type in a name. Because I already entered it, I can go straight to test. This was the name we gave it before. Back on the Vision AI platform. One more thing to notice is that if you remember, the empty set was null. Another was red, and the other was yellow. But the order is different from the names on the training platform. If this happens, please use the value here and paste it into the space here. We have to make sure that the order of items in the control box and the program are the same. Now, if you find that there were no mistakes and that the categories are all correct, you must then make sure the names of the categories and image training platform are also the same. Here, they are the same for the camera settings, like reverse or width and height. We just use the defaults. No need to play with those. Next, start identifying the images. Here it shows an identification name and the identification confidence. During identification, the confidence value affects everything. The one is the default example from the manual, so we have to change it to red. This is case sensitive. If you use lowercase, all the letters here should be lowercase. For a higher success rate, here we key in red. The most important thing is the confidence level. If the confidence value is set too low, identification may be incorrect. It cannot recognize left from right or will put it in the wrong category. How do we check this confidence level? We'll do that through the main control box later. We change the number 5 here to yellow. But that won't change the confidence level because we are not sure about the conditions. Later, if the screen has neither red nor yellow, what will happen? It shows null. After confirming all the program data, because we've confirmed Wi-Fi data,
and that main control box has connected successfully. We just hit execute. Then it will start the program. It'll send it directly to the main control box. Next, let's take a look at the screen on the main control box. After it loads the program, it will recognize that there are no objects in front of it. So it'll show the new screen. Now let's adjust some parameters. During the process of fine-tuning the parameters, the background can end up affecting the values. The data settings you see now are suited to my current environment. If you do the assignment later, please adjust it for your own environment. See here, when I place a red cube, the confidence value is as high as 0.9 or higher. So now we know that it can distinguish red cubes correctly. Let's remember this number. Next, we'll try a yellow cube. This yellow cube was recognized as a red cube. That may be because of its shape or its position. If it's identified as a red cube, we have to fix a few things. Did you find that although it gets recognized as a red cube, the confidence value was lower than 0.9? It may never reach this number. So, it's important to set the parameters correctly. When will it be regarded as yellow? Let's move the lens. Sometimes it will appear yellow. From this angle, it shows yellow. The confidence value for yellow is between 0.6 and 0.7. In order to improve detection rates, we can try setting it to 0.6. For the red value, what number should we choose? Because the value is very high, we can set it higher than 0.9. Yellow here has some arrows, but the value doesn't reach 0.9. The red threshold above 0.9 would not activate it. But if you want to activate the yellow part, well, you may need at least 0.5 or 0.6 or more. We can use these parameters to adjust the content. Next, we change the data in the program. Go back to the program editor and you'll be able to make changes to confidence cutoff. So, where it says red, we can put a value so that when we place a red cube down, the confidence value is high, usually more than 0.9. But for the yellow cube, when that is getting identified, the confidence value has one part that is recognized as red. That means if we don't set the value properly, it may recognize the yellow cube as a red cube. When it is a red cube, it must exceed 0.9. So we can set 0.9 as a safe number here. That way, it won't make incorrect decisions.
For the yellow part,
I just found that when it's identifying the yellow cube, it is often seen as red. But when it recognizes as yellow, the confidence level is relatively low. So we have to set its confidence value to around 0.6. Let's do that now. So when it sees the red cube and the confidence value exceeds 0.9, it will be classified correctly. If it identifies a yellow cube because it doesn't meet the 0.9 confidence level, that's okay. It just has to get 0.6 or more for the yellow. Going forward, we can use the 0.6 as the standard, so it can make correct assessments. Now, we must remember the parameters are affected by the environment and the background. You need to adjust these values according to your current situation. We also need to teach children how to account for this. Once the values are adjusted, for example, here we have lights on and off, and then divide things to left or right. These are defaults, so you only need to adjust the parameters here this time. Once you've done that, you can hit execute, and the program will be sent to the main control box. Then just assemble the control box as part of the model, and you can sit back and watch the result. So the moment has come. Did we get it right? Let's take a look. These cubes to be classified are determined according to the model you just created. What do you want to classify? Here we use a simple example. I use red here and yellow there. After identification, the respective light will turn on. And for this challenge, we only need to sort the blocks 5 times successfully. Let's take a look at the first round. Success. Second time. Success. Third time. We need to adjust the position a bit. Success. Fourth time. Because its lens is here, it needs to be aimed. One more time and... Success! We managed to sort them successfully 5 times.
Okay, let's take a break, and you can enjoy this short video showing some of the awesome models.